Hello, everyone, and welcome to the broadcast. Today, we are going to be continuing our coding project. Huh. We are going to be attempting to get the new rendering in collision solidified here. We had some success on one part of it. We need to follow through on the rest of it before we can actually start changing everything over. Hey there, Oleg, welcome. Let's check in with the kitties. We can see 4 of 5. Sherbet and Mason are on the bed. Ember is beside the keyboard, and Sammy is on the shelf. Sky is eating some kibble, which I laid out early so that he won't go into mischief mode when he gets hungry arbitrarily. I actually got some dishes that are oriented towards not the cat's not getting into that stereotype of the food's all the way to the edge, so they won't eat it. They are shallow, rounded dishes that are elevated, so their whiskers never touch the edge or the bottom of the dish when they're trying to eat, so it doesn't bother them to try. That's often why a cat will complain that it's hungry even though it has a lot of food, is that if it bumps their whiskers when they reach for it, there are plenty of cats that don't like that. Since bumping whiskers too close to the face means they can't fit, so they definitely can't reach it then, of course. Let's go with the standard. The bed camera is very reliable. Okay. So last we left off, we were working with our test render object here. We're an educational channel, except when we're completely not. I am wrong very often, so, take my advice with a great big bag of salt. I think the switch to piano was the right option. I like me some somber piano. I wish I could find more cello. Big old bass cello, Okay, so here's our rendering logic. We do need to put this in. Hey there, Zell. Welcome. We do need to have the rendering logic on a pure item basis. Or at least we need a series of canvas items associated with each entity. That will follow later. Just notice the pun. Well done. Okay, so we're going to create a series of entities that have going to be a lot of test objects. So the test render has an area 2D. That's where we want to start. That's going to be the area that gets loaded up. We will then create a new script that is just a test thing. Very descriptive names, I know. Does not extend a node. I want as few nodes as possible. Nodes have overhead. Nodes are part of the tree structure. 2. We have a position. Sprite as a how are we doing that? As a rids. Test render has a sprite reference. Okay, we're going to do a canvas item. Each of these will have its canvas item, and then they have a texture 2D. Which we would normally do as a load, but we'll have to get that in there. When it's a node with exports, we could go in and say, "Oh, here's the texture in advance." That's where templates will come in for this kind of thing, I think. So, ready. Oh, okay. But it doesn't have that. It does not have that. String which has a get. It just has a set. Path equal to path. Man, I'm hitting all the wrong buttons. So then texture is equal to load texture path. So if you set the texture path, it updates the texture. It extends object. Okay, don't have to worry about it then. I was worried we might have to free it, you know? So we've got a canvas ID and we have a texture for it. So we can initialize it by having it get a canvas ID. Get our code here. We create a canvas item, and then we set its parent to whatever the node parent is. So if we initialize it with a parent object, then it should be able to do its initial canvas setup. Hey there, Laura. How's the Battletech been going? Canvas item gives me an RFID, not an RFID. Well, I mean, that's the way to do it. It's what makes EDF and Helldivers so much fun. The idea that war crime is a piece of equipment and that you usually have choices of which one to equip in any given slot. Okay. Function. Oh. Exactly, Zell, since especially since the patch that fixed gas strike and napalm in multiplayer. Becomes a universal problem solver. Burning poison gas. Initialize. Yeah. There are a lot of people that got knocked out of being able to play Helldivers. That's one of the beautiful things about tabletop war games um where you have the freedom of creating your own factions without either the tournament or a fan base that is really rabid about not doing that, is you do get those wonky custom factions, the burninators, as it were. Bonus if all of your mechs are the speedy run up and light you on fire kind. If nothing else, Zell, there's EDF 6 to look forward to. Okay, so we have we go in and we're going to initialize, we call that a grand total of once. You haven't played EDF. Okay, so EDF is effectively Helldivers has a lot of actually like high quality stealth and more careful gunplay and the like. You don't take much, you can't take a lot of damage. You got to aim, you got to run and dodge. So less of that, more explosions and bigger ones, and the plot line is even sillier. Oh yes, and there's also like marching songs, lots of marching songs. I actually encountered an EDF marching song lore that I hadn't heard. That later in the game, some of the marching songs that the soldiers will spontaneously call out um, are a lot more, or are a lot less confident about EDF victory. I think one of them mentioned like a final eternal scream or something. We're getting there, Huge. We're getting there. we're working on the new collision, on a test of a new collision and rendering system. Use texture path. Which should trigger texture path there, I think. We'll verify. So we get the texture set. Ideally, that will actually load the texture object. Actually, we don't need that. We're going to make that part of the initialize. So we should not be changing the texture path or the texture itself once we're loaded. Oh, no. We don't do that. We do this. Okay, yeah, that's entirely why I did that. Entirely why we're passing the parent our ID into this, then there will need to be more variables than this in the future. So this is the where. This is the where, I think. And this is the transform. No, okay. This is the position on the sprite. And 0. Hello, Sky. Hey, bud. Sky needs attention. He has eaten his fill and is now coming over for ear scratches and to be held. But yeah, it's out. Lots of EDF games. Latest one currently available is 5. 4.1 before 4.1 before that. But the 6th one is soon on the horizon and looks like a ton of fun. What I'm actually hoping for this time is that we get an interface and controls that are not hard built for a given console. the prior EDFs had a lot of issues as far as have had a lot of issues as far as how they interact with PC graphics and the user interface of them. There's a whole lot of this is going to have full screen control and you're going to be using a gamepad, right? Kind of stuff. Like menus that need you to use the arrow keys for some options and that you can use the mouse and keyboard for others. But in exchange for dealing with all of that hijinks, you get very over-the-top gunplay and really, really, really cheesy old B sci-fi or sci-fi B movie plot lines and voice work. We always joke that a lot of the lines feel like they give a voice actor a vague idea of who is voicing the line. So, the voice for a given character is consistent, but it feels like they just randomized the lines. Like they took all of the dialogue for the characters, snipped it up into, let's say, single paragraphs. Maybe a little bit of call and response, but mostly just, here's the paragraph that your character says before someone else says something else or after someone says something else. They put those in a big old hat, and they have the actor pull something from the hat before they read it. Because sometimes it feels like the character is delivering that line with zero context. It's the cheesiest of goodness. This guy is getting maximum ear scratches. None of the others like this, but he really likes it when you get your fingers right in there, like you push the ears kind of down. Whereas the others will like stroking and scratching their back. He does not like that. He prefers back scratches and chin scratches. Oh, that is one of the cat cams there. Oh. I frequently get that misapprehension. The body looks young, and there is often the opinion there. It is the opinion of a lot of folks that means female by default, or technically that VTuber often means female by default unless shown otherwise. Well, the best way to learn to code card is to start coding. There are a lot of free tools out there, whether it is a pure coding tool like Visual Studio Code, or game dev engines like Godot, which we're using here, or things like Unity or Unreal Engine, those kind of things, where there is no upfront cost to working with them. And just great big piles of good tutorials out there. Mobile would actually be a hard time. Yes. You definitely need like a PC or something. I have no idea, Huge. I haven't encountered Luna personally. So we initialize it. We call draw. We have it get a delta so that during the visual update. Time since last animation frame. Ooh. I mean, I'm all for verbose names, so... JavaScript is one of those... It's meant to be flexible. You can see some of the mentality behind JavaScript in a lot of scripting languages like this. All I need to do is use this part. These are variant types. This is the variable is whatever I put in it if I don't declare a type. And that means you have to know precisely how the code works to make it work right. There's no fundamental typing control. There's no fundamental air trapping, that kind of stuff. You have to do all of that footwork yourself. And not because the functions don't exist like in your C and C++, where you need air traps because the language will let you shoot your own foot off. JavaScript it's so flexible and loose to allow you to just get it done that it's really easy to get it a little wrong in a surprising and unexpected spot. Hey there, guy. Welcome. Welcome, similar but legally distinct from Spider-Man. Oh, it's not the last update. I don't need to be this precise. It's a testing object, but habits die hard. It is better to have a very descriptive variable name than it is to have a vague one and make a mistake. Verbose it is. Hey there, Abraham. Doing pretty well today. Right up there with loquacious. You gotta love archaic words. Heck, my name contains one. Newtmechanist. Still coding the game. To animation offset this one. And modulo 6. Update equals delta. One. So this is which square on the sprite sheet we use. This is where to put it. It's clear in it. Yeah, there we go. You know how... I'm not sure what your question is there, Abraham. I do not. I presume that it is some sort of like pseudo Skynet kind of scenario. The thing that... Is this the thing that controls the robot dinosaurs? I've never played those games, but in a world where you have robots running amok, there is often a malevolent or inhuman, inobjective AI behind them. Hello there, Blue. Okay, and this is... add it. We move its transform. Okay. So when we tell it to draw, we give it the delta. This is going to be in like the frame update. Yep. A not uncommon narrative with an AI where humanity has been kind of pushed to the brink in a fashion associated with it is that the objective of the AI, the thing it was built for or similar, eventually leads to a point where humanity is in opposition with its goals, and it either ends up being a, for the good of humanity, I must do this thing that humans don't like, or humanity is a problem for my objective, and thus they must be removed. A common thing, which is definitely not something that plagues the Catbot Corporation. Catbot Factory is definitely still fully under human control, or at least human oversight. Everything is fine. So we have the rendering. We're going to put this in here so we can ID it. And this so that we can get the rest of it. So the area 2D. See, I could make this to be an area 2D, the whole test renderer. So we're adding things to that area 2D. That's probably what we're going to do ultimately. But for now, so we don't have that. Don't have that or this. Quickly, seconds passed. I like the other one. Have that. We don't have a shape ID. We don't have a current position or direction. None of this. We're going to leave some of this in for a bit here because we need to be able to set up the shouldn't need this because right, it is, this is enemy layer and it's looking for the player, it's looking for the player layer. An intentional rhyme. We need this. Not that. Well, Abraham, I am the proto-nanotype, the first, the preliminary version of the new product line of the Catbot Corporation. As such, all of this damage is definitely from the testing process and was here well before the initial handoff of power from the lead engineer to me. And it was in a fashion that was entirely consensual and in line with the goals of Catbot Corporation. The lead engineer even donated his mental engram to me in a completely non-destructive way. He is fine and is on vacation. He decided to get rid of his phone and not tell any of his friends or family about where he was going. He wanted to go off the grid forever. Need the body. We're not creating an area. Nanotypes are always sentient. They all have a basic set of motivations centered around aiding their owners, and they're all bound by those Asimov rule things. Definitely keeps them safe. I mean, their owners safe. Add a thing. Box is 16 by 16, just so that we can this is one of those terrifying functions. It's a very low level function. So instead of having a bunch of overrides for this or variation functions on it, like having different shape RIDs and you saying, I know, so shape set rectangle data or something like this, what this second property is or what you pass into this function is entirely based on knowing what kind of shape you created earlier. So I create the shape and I get a resource ID. Then I make this separate call. I pass in the resource ID, and I need to know which one of these functions I called in order to know what I'm passing in. So if it's a rectangle, I give it a vector that represents an object that contains two float values whose values will be used to determine the width and height of that rectangle. If it's a circle, I just pass in a float that is the radius. Completely different objects get passed in. And this is where things like JavaScript and even this language at a low level run into problems. Because if I don't have full knowledge, like if I don't know why I'm calling set data or what kind of thing this shape is, then I might mistake what I should be passing into it and get a error case. It's essentially down this road leads lie pointer errors. Okay, so in this, we are going to do our new thing as a test thing. Test thing dot new. You go low enough level in programming and you can replace the language that you're programming in with RISC surface. Down at the C level, you can be wildly efficient. You can be very precise. And you can bring the entire program down in a violent way that results in a single error message, segment fault. What precisely did generated that error? Good luck. Int 0 string form of thing count? I do plus plus. Nope. Yeah, we'll do this before. Initialize. Area resource identifier. Okay, so we set the new thing up. Range, and it will be anywhere between 96 and 480. Anywhere between 1 and 5 squares. Not sure what you're referring to, Abraham. A pined cushion. So, do you mean a pin cushion? The, tightly wound, heavily stuffed fabric ball in which pins are kept for sewing purposes? Or do you mean a pine cone? Which, the seed-bearing pod of a pine tree? Hello, Chris. Hit the shape. Let me add the shape. Ah, okay. The Nergigante. Interesting. Monster Hunter monster reproduction is something that they touch on only lightly with some of them. I mean, there are the obvious ones like the Wrath Wyverns, but some of them not so much. Especially when you get into Elder territory. Hey there, Cat. Indeed, that's 2 of the 5. Good opportunity to switch over since we've been largely sitting there staring at the screen thinking. We should actually have all 5, yeah. So let's see. Sky and Ember. Sky is using Ember as a pillow there. We have Sherbet and Mason on the bed, and then we have Sammy off by herself. So 5 kitties. Transform 2D. Sneak to transform 2D. Scaled.translated. Need to be scaled. Hello, John. We're working on a physics and rendering system here. Structure. I don't know if it needs to be scaled. Because I like my cats, and I like to show my cats to everybody. The cat cam is a critical feature. Set shape. Set shape transform. Since the index will be 0 based, we'll do that. I think it's 0 based. We'll find out pretty quick. Gormagala is the virus spreading one in Rise, and that appeared in the as a kind of flagship villain monster in a prior one, right? The frenzy virus one. RID is equal to that. I remember that it becomes kind of white and gold. I can't remember what it was called, but that sounds about right. So so we create one. What we're doing right now, for those just joining as well, is we're testing a new physics and rendering system. So what I'm creating here is logic to create a thing in the world. We should start off the parent RID too. But anyway, we create a thing in the world, and we attach it to a collision zone. Then whenever we want to update its position, let's do it a different way. We're going through and we're creating a shape, like a box or something like that. And we're associating that with something that has an image. We put that shape in an area that we can detect when things enter or leave. If they touch one of those shapes, we move it into position. Then whenever we need to move the shape, we would come in here and say, here's your new position. Whenever we need to draw the sprite, we tell it to draw it at the same position that we have moved it to. So, like our position value. So whenever we set the position, so we're going to update it. Then we need the parent RID. We don't need the canvas parent, but let's keep it around. Not familiar, but I did see, amongst other inspirations recently, Pirate Software kind of gave me the little poke of motivation I needed to say, You know what? I'm actually going to do that, and I'm going to do it on stream. And I'm thrilled that people enjoy coming to watch me make this game, but simultaneously, I'm often baffled that this was the thing that did it. Or at least that people still like this. Okay, so area RID is an RID. Shape RID is an RID. I remember somebody that had a name with no symbols. And so, hello, hello. I'm gonna assume Cat, and Jakey. Hello to both of you. Okay, so we want to keep that so that we can move it within this. That will be useful. Well, if you mean you're in the car driving, please be careful. If you just mean you're in a car, not driving, then okie doke. We're gonna do. No, we're not gonna do a set. That. It is generally wise to never reveal personal information on the internet. Oh no, this is not the canvas parent, right? No, that is the canvas parent. So now we need... This thing is the canvas. It's not the area ID. Okay, so this is the area that we're going to attach it to. This is a shape that we've created. This is the rendering surface of the test renderer. And then this is the resource that we're going to use to render it. Where we are still on performance at this point. We are in the process of testing a way to do collision and rendering at the lowest level available to GDScript without getting into like C code. And hello, Copper. We are once again redoing our physics system, and as a result, we're also redoing our rendering system. The core goal is to minimize the amount of stuff that is in the node tree. Everything we're doing here is outside of the highly abstracted Godot node tree here. It just going to do area. need the shape. In general, where C# libraries, to my understanding, will limit you as to where you can deploy them. Since not everywhere is going to be able to tap into that effectively. But if we're very careful about how we interact with this stuff and we're not doing a great deal of computation, we should still be able to get really good performance. One of the things I'm deriving this from, let's see. There you go. This is bullet entities being created. It's just a little looping GIF of it, but this is a system where they're creating piles and piles and piles of them. I'd rather spend the time now, James, than have the thing detonate later because I put the wrong data type into something and it doesn't go wrong until, like, 50 function calls down the stack. Where was I? Okay, we give it an ID, we give it a parent area, and using the parent area, we're going to create a shape. Set its rectangle extents here. This will be something that in our real implementation we will set differently. So then we're going to add the shape and set its position. It will enforce the type if you set it. So if I say it's an RID, it won't, I don't think it's really compiled, but it won't process the script properly until if it receives a non-RID. Like, at runtime, it will error out, and it will try to catch it elsewhere in code if it tries to interpret it and it sees that you've made a mistake, it will try to warn you. And if at runtime it receives the wrong kind of thing, you will get an error. And that's largely why we're doing this, both for legibility of the code, but additionally, so that if you do it wrong, it blows up. It's better that it explode than that it proceed along for too long. Position as vector 2 is equal to if that's what you'd like to do, Daily. Shape and position the shape. Not really a new position. Overly verbose, but we're only going to use it the one time. I was still capped out at 750 where. And 750 is just enough to fill the screen. We ideally will be able to get 2 screen radius. And that's 750 monster objects. So no bullets, no pickups, no extra screen UI or particles. Ideally, I would like to be able to hit like a couple of thousand with no slowdown. So 30 to 60 frames, a couple of thousand entities. That should give us plenty to work with. We have made progress. Moving things, like culling objects down that are too far away, only animating only updating the animations, checking those kind of updates on a more restrictive basis. We trimmed everything down, but I think we hit our limit as far as actual tree-based entities. So collision-shaped children of areas, that kind of thing. That's why we're trying this direct rendering. Like, we are saying, draw the sprite at this, like, draw this part of the sprite image to this part of the screen. And we're doing that directly to the rendering process. We're doing the collision-based movement. We're doing that directly at the physics server layer. So the existence of the area 2D and it broadcasting collision messages will be in the tree, but moving the shapes around and all of that will be at the physics server level. Which will hopefully work. That's what I'm hoping to land on today. Create it, we set the shape data. add the shape to the area. Hmm. Oh, it's verbose, but you know. To that. I wonder if they have a notation for like setting this. I know some languages have a notation for like set this value to this thing in the description of the function, but but RI area RID to use. Really need the canvas parent after we use it the first time, but I'll take your word for it. Where? Set them. We're going to get the shape. Then we're going to set that shape. We're going to add the shape to our area. And we're going to use our position. We're going to use our ID. This might not be ideal, but I can keep the convention here. Set the parent. If we get into particles, we're probably going to be looking at things like shaders and the like. Hello, Michael. Anything that's just meant to be like sparkles on the screen, we're probably going to end up trying to use something like a shader. This whole thing is for stuff that bumps into other stuff. We're making a game, Michael. And in particular, we're testing out the creation of a new physics engine for a game. I think this will work. This. None of that. None of that. We're probably going to create a bunch of shapes in here. Our things is a test thing array. Array of. I think that's how we do it. There we go. Thing. Things dot append. Thing. Each frame, we're not. We're not going to do anything in rendering here. We've moved all this into the new thing here. No. Or thing in things. Draw delta. So every frame we render each thing. Each physics process step. We would do something with them, but we're not gonna for now. And we go into node, and we are going to do area shape entered. We just want this to happen. So it's going to create a bunch of them. These things are just looking for the player to touch them. Oh, we need to generate a bunch in our ready. I think I want randomize range from 1. I don't recall if that's inclusive or not, but we're going to add a thing. What game am I making? I'm trying to make a Vampire Survivors style game. Let's render create. Supposed to be on ready, so it should be ready. Means it should be able to get the RID. I remember this problem happening before. 2 ways, James. I have one screen that has an aggregation of all of them that I can see. Additionally, I have all 3 other windows listed together. So I can tell you're looking at the widescreen view of the YouTube stream. Because we're not getting anything here. Welcome back, Abraham. Oh. Fine. We'll dodge this. Let's see. This is stream 34, I think, and generally I work about 2.5 to 3 hours on this per stream. I have been working a little extra time out of stream on this particular part because we're getting into tricky territory. Into our test render. So by the time on ready happens, this is already set. or should be. Nope. So, ready. There was a way I did this. Oh. By the time this exists, I should already have this here. This isn't set at that time. Was that null? Not 100% sure on that, Michael, but Steam would be a great target. Made something for that. Dodged one of the issues by doing this. Dodged one of the issues by having all the objects added to the collision zone directly. I do not, Jonathan, but that is something that frequently happens to me. Sometimes names just don't click. Raycasting, removing the raycasting may help. Ultimately, we would still be throwing a ray to them, but yeah. The raycasts are much more to redirect them when it happens. Where did I put that? Okay, it's that I can't get them on ready. All right. How we do this? Okay, so we can't do this. Boolean is equal to false. In our first frame, waste of an execution line to do this check, but it's not a whole lot. Okay, what's going on? Why is area 2D not set? Because this has that entity. This variable is set to that entity here. It is set there. Which means we have it by the time that a ready happens. Or we should. But we don't. Like, I'm literally doing the same thing in the mob body. Yeah. We're getting those nodes. Now, we don't do a ready here. Not doing anything with it. But in physics process right away, we are potentially interacting with some of this stuff. Support. Welcome back. Category, subdirectory, enum. Yeah, I should be able to do this. right, let's try with that notation. Then in ready, we're going to set that. This does not exist at the time. Why is that true? This is not getting set. Despite the fact that it is very much not there, or is very much there. We're going to pause for just a moment, folks. It's a good opportunity for a break, and I got to look some stuff up. So I will be right back in a couple minutes. More like a few. Okay. So, we ran into this problem before, and we got around it by passing in the values explicitly. So, we did export. But that's not working either. I tried this as a variable, but... Hey there. This is Godot engine, Halbert. Double cat task. And I did see that graph that you sent me, Tass. It is... I mean, it's kind of to be expected. That kind of... the opinion being combated there is, I don't care what the data says. My friend's cousin's nephew's aunt's third removed is has said that they saw a thing happen this one time, so it's an epidemic. Sherbet has come for head scratches. Good opportunity to do a quick cat cam check. We have, well, 3 out of 5, not bad. Oh no, 4. Sammy's in the play area, kind of sprawled out. There's almost never somebody in the play area. For those in widescreen format, we're going to zoom in a little bit. If you're in tall format, it doesn't really change the size of the image. Yeah. Sammy is cozy. Oh. We get to here. We're at the end of ready. We're going to look at our remote tree. Game object has a test render. Does not have its area 2D. Why? What? But why does test render object pop into existence? Oh. This should be a... We should be able to add a test render here, and it'll be fine. But we'll stick with this. I'm making a Vampire Survivor style game, Halbert. currently what's cooking is a new physics and rendering bit of logic because I need better performance. We can only get 750 things on the screen, at which point frames per second tank from 60 down to like 15. There is some sort of threshold that gets crossed by raw node handling. So we're going to bypass it. We're using the physics and render servers directly. Okay, so we're going to create one, and that will ensure that this onReady is equal to... Now we're going to use the export. Yes. This will totally be here when that happens. Exactly, Halberd. 750 is about what's necessary to fill the screen with enemies. And we need to be able to sustain that as well as approximately the same number of projectiles. It's not the right value. We are... It's the thing count, and we append the new thing. Then we're going to go into our code for this. And we're going to touch one. Ah! Okay. But the collision area is off a little bit. But this is better. This is better. We are close. We are close. Next, we're going to go in to our test thing. And we are going to copy this. Sammy has moved to my lap here. Actually, there's almost never a cat on the side of the desk. We're going to remove the scaled from this translated. Also going to... Okay, yeah. Since we're interacting with the render server directly, the collision shapes... We shouldn't need to scale the transform of the shape. Position. Position. It's where we're rendering them. All right, that should have put it back. area. Even if I remove their collision entirely, where they're not looking for anything, uh, the it still caps out at about 1,000 entities. It really does seem to be a number of things in existence. That's why we're dodging the node tree. Ultimately, we may have to revisit the physics, like the raw collision testing kind of improvements. Okay, we're going to call get on the same thing and verify what we get here. Server 2D area. Yes, I know, Sammy. I stopped. Transform is area RID ID. Debug. I don't know if this thing has a toString, but we're about to find out. $70. And they're all positive numbers, and they're ranging between 1 and 5 squares. So what we need to do is see when we get that collision. Okay, no, we bumped the top of the box. Yeah, shape index. All colliding was 0. Oh, no. Local shape index. Three, 5, 9. There we go. we're colliding with local shape number. This is the remote shape, but these are the ones we've created. Now we're going to change this. So we're not going to use thing count. And we're not going to have an identifier passed in. Because we don't need to know the identifier. Because it's the index in the things array that matters. So this is whatever, this is the index in the array. We're probably going to use, I will probably use circles, but to some extent, that's going to vary based on the thing. So I may need to have logic that makes it arbitrary, which shape it creates, and how it computes it. So that I can then go in and say, this is the type of shape, these are the dimensions to use for it. For each enemy type, because some enemies will be bigger or smaller, some might suit circles better. And interestingly, where the circle shape is easier to compute, but I've heard conflicting arguments on whether a collision rectangle or a collision circle is easier for the physics engine, which is weird because you would think circle, wouldn't you? I don't get why the rectangle would be more efficient, but supposedly untransformed rectangles work better. I don't know why. Like non-rotated rectangle kind of thing. Okay, we're gonna see if this works. So it is going to physics server free RID physics server our local ID is equal to physics server. Area get shape is area. Okay, that's a problem. Local area RID. Area RID and shape index. Free that RID, and we are going to do things dot Let's erase. What did they do in this? Immunity. I could have sworn I saw a for each in. Okay. Okay. We're gonna remove the entity that we got. Okay. Erase things. That. Add thing. Okay. We are going to, if we touch one, we're going to try to remove it and then add a new one. Okay. Oops. Okay. So what was happening is when we were removing them, we aren't freeing the canvas items and we're not clearing them. Okay, there's no clear. Okay, so we're going to remove... Oh. Okay. We can do that. We're just going to do remove. So the assumption where, as to why I'm doing this, is that the overhead of the tree for creating all of the collision objects and the visible objects is cumbersome. Get a link to that tree. This is the page that that has an example of rendering server. I found multiple instances of people calling out that that's a good route to go, and the Godot documentation asserts that render server is more efficient than raw physics bodies for large numbers. There is another layer which is a collision mesh, but there's an extra layer of complexity to creating the visible objects that I don't know that I want to commit to just yet. But if this falls apart, we could go that route. But collision mesh is not for thousands of objects, it's for tens of thousands and more. Like drawing giant schools of fish in the ocean kind of thing. So have if you're willing to go down to the sea level, there's definitely some optimization for collision detection and the like that you could do. Okay, so we're just going to remove it here. So instead of going in and saying create the RID here, we are going to... Yeah, we'll just do it here. Oh, okay, I see why they did it that way. Yeah, we're going to call things index here. Remove. Take this. And do shape. During server. This item. Here. This item RID. Canvas item RID. This should scrub the object from existence here. And then we are going to remove it from the list and we're going to add a new one. Okay, something is going wrong here. It's possible that we're still colliding with the wrong thing. Because standing here, I'm colliding with everything over and over. Yeah. we're going to do this. We're going to remove the scale from it. Still happening. It's like the entire thing is happening only at about 0, 0. Watch, I'm gonna... The minute I touch the center square. Okay. Shouldn't have a size. The area should be infinite. It's the shapes that should have a scale to them. Okay, so their shape exists like here. We have a constant for this, but okay. So, should be the whole square. A little bigger than the whole square. Well, that blew up something. Yeah, huge. I was going for kind of a little classic bounce and squish on them. Can't set its transform until we add it. Okay. It's making them a little bigger than anticipated here. It's like the whole area. Okay, the indices are not what I want them to be. Okay, what if we stored them in a dictionary by RID? That won't properly get rid of them when we remove them from the dictionary. What if instead of... What if we index them by RID? By their shape RID? Okay, we are going to do... I'm going to have to look up a way to see if I can define a dictionary, like what's in it. Hey there, mafioso. Thing. Not shape ID is equal to new thing. Hey there, gamers. Or Chamu. Okay, so we add that. And then we have the local shape RID. So local thing as a test thing. These are all testing variables. Things. Local shape RID. Local thing dot remove. Base local shape RID. Add a thing. Oh. iterate over a dictionary. Okay. Thing key and things.keys. Thing. See thing. Test thing. Is equal to things. Thing key. Thing.draw. They still exist, like, right there, right at 0, 0. Hey there, 3. Our physics system is still not done yet. They're definitely colliding. And hey there, Mike. We're colliding with all of them at this point. I did. 1 second. Sherbet is passing in front of the camera. Like I said, it's a matter of practice, 3. Why are they all here? Okay, how about... I don't think they should be scaled. Doesn't really make a difference whether they're scaled or not. How are we going to tell where they are? Because part of the problem is I think they're rendering at a different spot than where the area is. Add a thing. Get our local area ID. We get the canvas ID of this. As their general positioning as far as rendering is concerned is right. And I think we've got this part working. And generally this part. Sammy was not visible last we saw. Let's do a quick check. So I think this will help us get the right shape. The test code that I linked or at least the code for the bullet hell thing, the trick with that is that it doesn't care which bullet actually hit, because any bullets left will just say, okay, I'm going to move my RID wherever. So, you know, if it still exists, if an RID still exists, then we're set. We just remove that one and shuffle the RID or the shape around. I like Dragon Ball, and I like early to mid Dragon Ball Z. Past that, the wheels start to come off with Dragon Ball. Like, they really quickly start to come off. One Piece, I've read a lot of the manga. At this point, it's sunk cost fallacy for me. I've read so much of it, I would kind of like to know how it ends. But it's always been kind of slow. How could we... Ah, okay. That's largely where we're sitting, and what we're up to here is we're creating that kind of entity, is that this is something that will feed it there. The problem is it's relative to that position as opposed to relative to the world position. But that shouldn't matter, should it? Because these are rendering about where you'd expect them to. Let's... Yeah. So... within... yeah, this kind of area here. Well, about around that area, you know? Ah, no, okay. Should be about... yeah, like that. This region here. Ish. So they're rendering in the right space, but their collision zones are all right about here. But the transforms seem right for when we're moving the boxes. Debug. Say string. All the transforms for the area shape. What if so I haven't found the variable for it yet but as far as collision checking, there is supposed to be a quad or oct tree that it cuts it down by. Like there is a collision optimization, like a heavy one that happens, that is culled down by like masking. The collision pairs, you can actually see them being generated at different amounts. There is supposed to be somewhere a variable that determines the size of the for 2D, the quad grid, that will cull down collisions. Where if you make it too small, it won't actually work. If you make it too big, there's no point. But between that and proper masking, so like my collision thing only checks for collisions with the player, so we don't get collision bodies generated for anything else. But ultimately our problem is that it doesn't seem like this transform is working correctly. The local transformation. It should be handled by the physics server itself. So all of the collision that is being done should be happening in the physics server. So the stuff I'm giving it should let it handle that. And we're trimming everything down to the raw, like the minimal objects it needs. So we're saying here are the shapes. They're not collision shapes. They're not nodes. Here's just a shape to add to that. Yeah. But again, right now I'm not doing the ray casting. These are just squares. If we can get this optimized enough that they just bump into each other, I'll take it. Like, we'll go to they have squares and we'll deal with that going forward. We can always tweak the kind of jittering motion later. There's more room in the wide view 3. It can fit more in the same in the screen space and wide. All right. Just hypothetically, if we area transform as a transformation 2D is equal to physics server server 2D dot area get area get transform, and this is going to be our area RID. Area transform dot translated that far. Unchanged. Okay. So it feels like this area here, like the entirety of it is tiny. Or that all of these areas aren't actually being moved. The shapes aren't actually being moved. Oh. We're only moving shape 0. Okay. How do we get an identifier to move it? we have circled back around to needing to get the index of a shape within the area. The pattern that I listed, where again relies on the fact that it doesn't really matter, aside from removing an RID, which bullet is which, like which shape you actually ran into, as long as you remove that corresponding shape. So if I remove item 3, I remove its RID and just shuffle things around. Effectively, I just remove the bullet at that index. But there's something more to this. There's got to be something more to this, because so we're moving them, and it's okay. This is just removing them from the bounding box and getting rid of them. There is no collision logic that they're showing here. I would need to get to see how they're handling collision to get a better idea for that. Because right now we're not translating them. That's why this is all happening at 0, 0. Okay. We're closer. We're closer. Quick moment here. Yeah, physics server is like the guts, and the documentation is very sparse. And some of the tutorials are out of date. Hey there, Olga. We could iterate. I don't like the idea of iterating. Because we'd have a lot of shapes, and that's going to create we're gonna go from we're gonna rapidly reach the idea that every collision could be an n complexity. That seems sloppy. Those params. So here's a possibility. We could remove the shapes and re-add them each time. So instead of like sliding the shape, like going in and saying, this shape, move it here, we could potentially just say, remove this shape, remove all of the shapes and put them back. But that requires us to constantly iterate over them and replace them. Oh, okay. I see what you mean. So yeah, there's the possibility that they strip it. There's also the possibility that they're the type of programmers, or the people that wrote it are the type of programmers that are offended by the idea of in-code comments. I've worked with programmers like that, where the idea of comments in the code is like bad. Like the code should speak for itself type. I have seen it, 3. I have seen Happy Tree Friends. Here's our problem. Gore is pretty much the entire premise of Happy Tree Friends. It's moving them is the problem. Hey there, Dread. We're working on a physics engine. We're in Godot. We're trying to identify a specific object so we can move it. We're having difficulties. Welcome back, Cat. The difficulty that I often see with people that don't like comments in the code is that often those same folks are the ones that end up using like a lot of one-letter variables because they think that, oh, well, you should know. It's more, put it a different way, is that mindset tends to lead to you should know what the code does, as opposed to the code very clearly explains what it does. We could iterate over all of them and update their position all at the same time within the code. I don't know if that would trigger inline stuff, but it shouldn't. It shouldn't trigger inline collisions. So one possibility is when we move, like, we're going to move all of the entities largely at once. That would make it so that movement of monsters would be potentially very cumbersome, but would allow us to handle the whole processing at once, which isn't out of the question for things like Vampire Survivors, because mob movement if we're doing it this way, shouldn't be individual creatures. Like, monster movement is just move them towards the player. Straight line towards the player. If there's a collision, they slide slightly off of it. Truncate the movement to the point of collision and continue along. Make it as dumb as possible, essentially. Area. So I don't like this because if we're iterating over every single object to move them, then isn't that going to create a burden on the physics update? I mean, that's what we're doing here. Yeah. So what this tells me right here is, as far as position of the shapes, the system doesn't care. Is what we're doing is we're iterating over all of the shapes, and we're saying this shape lives here. So we take an individual bullet and we say, okay, here's its position. We shift its position. And then we're going to go in and say, okay, set the shape transform of the index of the bullet. But we don't know that that bullet's RID conforms to the RID of the colliding shape. About 700, no. I mean, it's a start where, but that only fills the screen. It's, if I account for a hollow space around the player, then that's still only enough for the monsters. Which means no bullets, no pickups. And that's assuming that we cull things a little past the screen. Which isn't enough. We need, I want to be able to hit twice that. So I want to shoot for 2,000, but, between 1,500 and 2,000, probably enough. Because I don't need any monsters too far out, but they need to be far out enough that projectiles passing off the screen can still potentially hit something. I could make the creatures bigger, but working from what Vampire Survivors looks like, which is, they're at about the quarter of the scale, like pixel-wise, but we want to be able to get something comparable. So at the screen size that I'm dealing with, we're probably looking at about, that kind of 700 to 800. Potentially, I mean, like 600 monsters if we were to tighten the radius of monsters that could appear off screen. And just say, if they're off screen that much, it doesn't matter. We'll just not show them. They won't exist. And, spawn them in when there's an open space kind of thing. But that still would mean probably, let's say, 600 things before bullets. And bullets are going to be the things that cause the physics interactions that are going to be that much more expensive for rendering them. Because you're potentially going to have a bullet that slides across the entire area. You get like your Vampire Survivor's scythe weapon that fires great big projectiles over the whole swarm of monsters. Everything gets hit. I think this is what we can do, is for the physics update, instead of... We're going to iterate over all of the shapes in the area. We're going to get their RIDs. We're going to identify which entity that is, and then we're going to update their positions. Brotato, yes, Brotato has fewer entities, but it's also much more of a sparse arena. You don't get as many. You don't get as many things. And we're frequently going to have less than that, but we need to make sure that performance is just as good at maximum case as it is at minimums and more kind of average or median cases. Probably median is more accurate. Okay, so we don't want to iterate over it here. So that changes it. This set position, we need to know the index when we set the position. Oh. We could update their indices and then call them. Each time we remove things, though, we need to make sure that we go in and update the indices. And I don't want that to happen constantly. Like, we wouldn't want to have one collision and then update the indices. One collision, update the indices. Better that we update the indexes on collision. No, that's the same thing. Anytime there's a collision, we resolve it, and then we update the indexes. Anytime we add things, we need to update the indexes of the shapes. Otherwise, we're reliant on the pattern that they're using, and that's that, in the bullet example, and that's that it doesn't really care. It only cares that a collision happened with bullets. We could do that if every type of creature had its own collision zone. But that's going to mean a lot more self-collisions with creatures. Ideally, for optimization purposes, I think creatures are all going to have flocking motion, where instead of the mob body model that we've got, we have monsters. Those are a thing. They still have a visual appearance, but we could have an overall movement controller for all monsters. Such that I can do some sort of calculation outside of that and say, okay, this big circle and these little circles, position them accordingly, you know? But even setting that aside, we still need to be able to handle this right here. We need to be able to move an entity. So to do this, it needs to know its index. And I would love that the entity be able to move itself, so that I could put the movement logic inside of it. But I think we need to move it outside of it. Okay. Okay. So right now we're saying for each thing in. So for I in physics server area get shape count. This is area local area RID. Do a thing. In theory, this should be each index. Like, which one is it? I would hope, because every time a shape is removed, we know that the index is changed. Kano, we're making changes. I can create custom signals. The difficulty being, I still need to determine the index. And every time I make a change, every time a shape is removed, I have to go in and update the index on every shape in the array. Kano, we are changing how things are drawn to the screen and how they collide with each other. We're trying to maximize performance. So we could collide with many things a frame, and every time we have to remove something, every time a collision happens, we can get the RID, so we know which thing. So let's say something gets hit, like an enemy or a bullet strikes something. That doesn't fundamentally change the list of shapes in that area. But when the entity has to go away, so the monster is killed or the bullet goes away, it hits and it dissipates in whatever fashion, it times out, then that removes it. And as soon as the shape is removed, the index, the identifier in the area, like we have the RID, but the RID doesn't help us at this moment. That index goes away. No, the RID isn't the index. So let me show you here. As far as an area is concerned, this is the shape. It is an integer. It's a like 3. So I translate that index into an RID. I can use this to identify which entity was hit. But if I remove it, this changes. Like every one of the other ones could change. And the way it's described is that it goes through and like if I remove 3 from a array of like 5 numbered 1 through 5, then 4 and 5 become 3 and 4. So we're making an assumption here, and that's that they're linear. That index is linear. This is okay in process. Anytime we set the position, we need to know what its index is. So this could be a problem for us. This could be a problem. It's every time something moves. Potentially, like right now, 8 times a frame, 60 frames a second. So, 480 times a second, we are going to be iterating over every entity in it. Now, we don't know what the logical complexity of getting an RID of a shape out of the area is. But let's assume it's fixed. So let's assume it's a one line operation. It just directly grabs it, So that's still just n. I don't get what you're getting at there, Where? Complexity-wise, it's still... everything moves, so it's like n squared. Every time something moves, it could trigger a reprocessing of everything else. So every move is an n squared operation for the number of entities. Not thrilled. I mean, n squared isn't the worst thing. It's at most n. It's like... it's a standard linear search. Is effectively n, or it's like n log n or something. Okay, let's... So right now we have the things indexed by RID. What if... Okay, let's... Things is an array of test thing. What if... Go through this things and new thing. So let's loop back around to our original logic here. I do, Kano. If you go to my YouTube channel, then there is a LinkTree. So I still need to update my... I have to remember after the stream that I need to add a link to my music. Anyway. There's a LinkTree which has a Discord link. Which should work. I had to update it recently, but it should work. So we append it. And instead of that, instead of this, thing in things. Draw. That's fine, Kano. Oh, Delta. Every time it moves, it still needs its index. But we can just iterate over them and say, this is your index. One way or another, I think we need to iterate over the collection of things and tell them, this is your index, unless we intend to only have them move here. Where we don't trigger the movement inside of the object. No, we... Okay. We're going to do things dot... Let's count. So initially we're going in and we're saying that if there's nothing, it's index 0 at this time. And then we're going to add to the list after we're done with it, which will increase the count. Okay. Okay. So then in test thing, we initialize. It's also going to have its index. We'll do ID to use. Just an int. We're going to keep ID. Then we're going to use the ID here. Yep. Size. I always get size and count reversed for the objects here. Okay. So that's our index in add a thing. So in theory, local thing. Let's see if this actually pans out. I'll remove on it to purge it out, and then we're going to do that. Then we're going to call add thing again. So as soon as this happens, the indices change. But all we should have to do function remove thing index is an int index or thing in things. I in size means I dot ID is equal to I. Well, that was definitely written by a real programmer. Where? Okay, so if we remove a thing, we update the indices of all things. That should save us some pain. If this works. Feels good. It looks simple, but it's amazing. Ah. I've hypothetically fixed it, Tass. Fixed it forever, and it will never ever break again. Okay, let's look at our monitor here. No orphan nodes. No orphan nodes. So now we're going to look at our... where is it? Don't care about frame time. What we care about is memory usage here. Okay. So now we are going to go into this, and we're going to say 1,000 things. And when we add a thing, we are going to go anywhere between that. Okay. Okay. Now, they're not colliding with each other. This is still a portion of the testing that we should be doing here. So we're going to go into this, and we're going to say it also looks for enemies. It can collide with itself. Now, it would only collide with itself if it's moving. Okay. Oh, wait. It has to exist in the enemy layer to collide with itself. Okay. So they have not entered the area is the trick. So they can't collide with themselves yet. That's fine. That's fine. 10,000 things. Let's look at our monitor. $10,000 things, about 50 frames per second at the moment. Now, this isn't counting for movement. It's not counting for any extra collision, but we are rendering 10,000 things at once right now. We are getting some flicker every time this happens, because every time we touch one, we need to do some recalculation. But, yeah. This is technically horrible, visually weird progress. Oh, but feels good. Feels good. We will need Y position culling on it as far as rendering. Like, we don't want to draw them all on top of each other like this. That's low priority for now, though. Next thing is going to be getting them bouncing into each other. Like, can we get it to self-collide? Because if we can get it self-colliding, we can start seeing the maximum performance cost here. Actually, let's do another start of this. We need to look at our memory. Don't know if those are what I'm looking for. Objects, resources, and nodes. We aren't off. We don't have many of these, and we're not changing the number of nodes. Memory, texture memory, buffer memory, collision pairs. Collision pairs is the one that I was talking about. This is kept very under control by Godot's system if they aren't colliding with each other. And also if they're out of range of each other. So we don't do every time something moves, it might collide with everything in the world. It narrows it down. But if you have enough things close to each other, that might not be enough. Like, if they're filling the entire screen, there's still going to be a great many collisions. Now, each entity out of 1,000 might collide with 10 other entities. You're still processing a great many collision pairs. Okay. So now we are going to walk through a bunch of these. Yep. As I was moving, we can see more collision pairs being created. Let's narrow it down here. I'm not seeing any changes in the memory here. So we're going to cull this way down. At any given time, up to 3 collision pairs. As I'm walking through this mass, I am only ever colliding with a couple of things. Now let's maximize this. Oh. They're getting a lot of out of bounds. We'll have to check that. Hello there, Cheetos. Okay. There is out of bounds on the shape logic. We could have duplicate collisions here, because if something is set to be removed, we might need to remove it between physics checks. So we might have to yield, you know? Because if I'm guessing, what's happening is all of these collisions are occurring, but they might be occurring with the same entity which just got culled out. It's as we created them. So if I remove that, yeah, they're spawning potentially on top of each other. And when I'm removing an entity from that list, I'm potentially creating conflicts in that check. So, like, this collision happened, I remove the entity and add another one. Remove this. Async is not the greatest idea, by the way. But, things, index, move, was it, it's not yield, quick. Wait. Really want to yield. It was like defer or something like that. All deferred. That was the thingy. Thing. Tape index. Remove, then add. Still on the game there, three. Okay. Collide with yourself. Nope, that didn't change it. All right, three. Here's a fun one where if you're curious, when you look at an error code in the GD script, it will also tell you which CPP file the error happened in. Wait a minute. But that... Oh. Game. Lives in player. This shouldn't be getting called. These areas shouldn't be getting messed with. Okay. There we go. Malfunction with the other collision zones. I don't know why. Which is, par for the course with coding. Things happening, don't know why. But these are self-colliding now, or they should be. Let's have them move. So what we need is a way to connect a thing. Oh, no, we do have that. We do have that. So when we're removing it, but we need an ability when we set the position. Yeah. So one, we are going to for consistency. Negative. And then we are going to physics process for test thing in things. Thing dot set position. This is tricky. The question will be, when we do this, are we going to get position errors? Are we going to get out of bounds errors? We're going to find out. Range from 6. And we can save a operation here. Well, functionally the same thing. But for simplicity. So we're going to set it. We're going to set its position of each entity in the list to a position within 1 square of it. It's going to slide at a square per second in a random direction. They're just going to wiggle. Okay, so this is 10,000 objects wiggling. Don't need you anymore. Okay, the print debug was causing us a lot of pain. They are not self-colliding. They should be self-colliding. But again, 10,000 objects moving. FPS about 44 with 10,000 objects. If we lower it down to 2,000. 2,000 things moving. 60 frames a second. Collision pairs are not being generated. Is that because... No, they should be checking for each other. Look at that. Look at that, though. They're still popping properly. But we are not getting self-collision. So self-collision is going to be one of the next things. We do need to have the blobs able to bump into each other, or we're going to need a master handler for all monster movement that slides them around. Not out of the question, but I would prefer flexibility per thing. Again, worst case, everything just converges on you, but the ability to have things like a boss monster that moves around. All right, though. All right. That's going to be the end of it for today. We ran a little long. That is fine. That is fine. I'm definitely on board with making progress. It just tells you how engrossing it is for me to do this kind of thing. But we have a pretty good model. I think we still need to figure out that self-collision. I want to know why that's not working. But past that, I think we're in good shape. So, we'll pick up with that next time. Still don't know if or when we're going to pick up with the gaming. Again, we might do some double streams of coding, but I do kind of want to fit some games in. I just haven't decided what. Payne's Creek Killings is still an option. We can get back to that. Figure out how to count darts. But maybe something else. But in any event, I do hope you had fun watching today. If you like what you saw and would like to see more and have not already, consider liking, following, subscribing. That will help algorithms find more things that you like. So I hope everybody has a good rest of their day, and I'll see you next time.